Today I'd like to tell you about our Metro SDN project. But first I'll introduce my company. So what is Rostelecom? What are our services? What is our SDN strategy? In the main part, I'll talk about Metro SDN concept, about 2 pilots which we are running. 1.5 pilots which we are running actually, about the solution we've chosen for implementation, and in the end of my presentation I'll talk about money and so what lessons did we learn from that. So first of all, what is Rostelecom? Rostelecom is a national fixed wireline operator. It's the biggest one in Russia. So we have all types of wireline networks: access, aggregation, backbone, optical backbone, long haul, mid haul, and other things. So we are the biggest in number of and we run most projects. Other national leaders, we provide all sets of telecommunication services, different internet, VPNs, cloud services, Internet of Things, security services, and last year we launched into the production project. It's called Telco Cloud. So it's about providing 6 virtualized security services to our B2B customers. So I talked about this project 2 years before here. Now it's alive and it's running. This SDN architecture was developed at 2015, and later it became a part of our technical strategy for the Rostelecom. So the first key point is that there's no unified SDN at all. So we divided our network into 4 different network types and assume that we'll run different SDNs for each of them. So the main target for this architecture and for SDN is to have end-to-end automation of all the services and networks. So for wide area networks, we assume that PSEP and NetConf will solve most of our problems, like traffic engineering control and automatic service creation, modification, and other things. For optical SDN, it's the most tricky part because we have several proof of concepts with Nokia, Huawei, and Sakharchuk, but we still didn't understand what to do with this because it's the most closed ecosystem in all the networks. So all the vendors don't want to open any interfaces to their NMSs. They don't want to have something like open raw ADM and open interfaces. So we'll have something there. For metro networks, we've chosen OpenFlow and later P4 with NetConf. So I will talk about it later on next slides in more details. For data center deployments, we already implemented overlay SDN, VXLAN-based SDN, but to implement network-intensive VNFs, we will sure need to add something like OpenFlow, P4 or NetConf for leaf and spine configuration. So for Telco Cloud, as I said before, we use, or maybe not said before, we use SD1 as unified transport to get our customer inside the data center. For access SDN, we still didn't define the strategy. There are a lot of different initiatives, for example, in ONF, but we still didn't test them and have no economical estimations about them. So what is Metro SDN? First, this project became alive when we implemented and introduced unified metro architecture. So as Rostelecom is a result of big M&A, so we include, I think, more than 20 different companies inside Rostelecom. So all the networks are built in different ways. So first of all, we defined the target architecture for all the networks. It's still in progress, it's still not implemented, but in some regions it is. So when we defined it, we looked at it, and it was very suitable for SDN deployment. Another key point is that we limited the number of services which we want to provide inside this network. If you will try to implement all type of VPNs, layer 2 services, internets, and other things in any SDN controller, you will fail for 100% because it takes a lot of time and it's a really hard task to implement. So we defined that we limit the number of services to only layer 2, all of them, E-line, E3, ELAN, and multicast services. The next point is that we want to have only white boxes there, and we want to have unified network operating system for that. And for this network to be more reliable, we require to have a cluster of controllers to operate it. So, roadmap for this project. The first POC was done by 2 Russian companies in 2015. Then, at the beginning of 2016, we understood that to compare different products and solutions, we need to have unified test program, because when any vendor comes to you and says, I have SDN, they bring totally different use cases, and they bring totally different programs to test. So, we made our own one, based on our target architecture, and then we started laboratory tests. So actually it took us about 2 years to have a product suitable for first pilot. Then in 2018 we launched the first pilot, so I'll talk about it later, and we continued our tests. So we introduced new functions, we introduced new hardware into our solution. And at the end of this year, we will have second pilot. So actually the devices are already mounted, but we are waiting for the lab tests to finish to power them on. And after this pilot will be finished, so we will go to implementation of this across the country. So it's a scheme of live pilot. So it was done in the previous year. So we have 2 main goals for that. The first one is we should understand if this technology can live outside of the laboratory, because when you're in lab, you can do anything, you can fix it in maybe hours, and there are no customers there. So no one can tell you that something is not working. So we decided that we'll try this on real customers. And actually it was successful, so no one attacked our call center and said that the service is not very good and other things. So what hardware did we use? We used NoviFlow as distribution switches or core switches, and we use x86 switches. It's a small server with line cards located in the front of it. So it was from Russian vendor, it's Depot, and for sure we use x86 servers for controller. So the software for DR was from NoviFlow, and for AR was from Brain4Net company as the controller too. So this pilot was run for 10 months, and during that we built the parallel network. So next to the traditional one, and then at night we took part of our subscribers and reconnect them to the SDN network. So then we monitored SLA, and if something went wrong, so we connected them back, and if it's okay, then we leave these customers at SDN. So 10 months, okay, with this setup. So what will be the difference for the next pilot? The first one is that we are running ASIC-based switches. So it will be H-core, it's Broadcom Trident 2+. And for sure we'll also have servers for controllers, and all the software will be from Brain4Net company. So it's Russian guys. As you can see, we have slightly different scheme. Actually, the topology doesn't matter for this controller. It can run services in any way you like. But we introduced also parallel links, and so guys from this region asked us to implement multi-chassis lag to have some kind of load balancing. So we also did that. So what is Brain4Net? Brain4Net is a Russian company. It's a startup company. It also had some investments from Rostelecom after they showed us successful POC. So why did we choose that, but not some other solutions? Because the second Russian company, which was making tests for about 2 years in our lab, so after some time it disappeared. Said, guys, we're not interested in your project, so and went out. So we had only one solution. We tried to mate in on open source things like ONOS and OpenDelight, but at the time they were not mature enough. And so we didn't have enough developers to support this activity. So all the features which you see are tested in our pilot and in our lab. So the biggest challenge for Brain4Net right now is adding barefoot support. So because we heavily rely on P4 for our business case. So talking about the business case, as I work in big bureaucratical company, so to implement any new technology, you should provide TCO calculation, comparison analysis, and all other things which are known to you, I think. So we defined the greenfield region. So it consists of 35 devices of different types and number of ports. And so we calculated based on our current price list how much it will cost on one Chinese MPLS vendor and on SDN. For sure, the software was from Brain4Net and the hardware from EdgeCore. And so what we've got 20% capex reduction for the TCO for the SDN compared to traditional MPLS. So yes, you can ask a question that for sure any Chinese vendor can give you a discount up to 20%, I think that in several days. But the prices for SDN still can be lowered, so I think this technology have a good economical reasons to be implemented. So what we've learned from our long journey. The first is that, so actually the first line was shown by me, I think about maybe 4 years ago when we started trying SDN. So there's too much marketing, so most of the vendors have not software-defined network, but slides-defined network. And so when you ask them to come to your lab, so like, no, maybe we can go to the pilot, maybe you can buy us, but no tests. So the biggest problem with SDN is that there are no real guidelines. So when you step on OpenFlow OP4 way, you should understand that you will design everything from scratch. So you should define your service model. You should choose what type of encapsulation you will use, how you will swap it on all other things. You should define all the services. And then, if you will not make some mistakes, then you will have some working concept which you can implement. And another biggest problem is that what you have in your slides or what your engineers made can have problems with implementation in hardware. For example, you want to have MPLS labels, but some of hardware vendors can't use them, for example, right now, only VLANs. So another interesting thing is about OpenFlow standard. So several years ago, it was very popular that equipment have OpenFlow certificate, that it have compliance to some standard. And actually, this is useless thing because when you define your service model, you don't need all the OpenFlow specification. You need just particular things from it. You need particular tables, and it's heavily related to your service model. So there's no need to ask for OpenFlow 1.3 or 1.5 support. You should ask for particular things. How many tables, how many rules or flows you can place them, and other things. That's what you should ask for. Another problem is it's more related to ASIC vendors, is table sizes for OpenFlow. So you can have all the features that you need, but the tables are too small for you. That's the problem, because It's okay for lab, it's okay for pilot, but when you roll out it across your network, you should understand that if you add the service number 1001, that the device won't go down or won't say that, sorry, I can't. So it's impossible to have this thing with traditional MPLS routers because you know all the scaling information about them. Another critical thing is care grade. So nobody wants to have some solution which will break and won't be fixed. I mean that all the redundancy schemes, when the controller is out, when it's online again, the service restoration, all that things are extremely critical. And without them, there will be no implementation of this technology. Guys from Broadcom are very smart guys, very good. So they have OFDPA. But during the last 2 years, we found a lot of, me and guys from BrainFonet, we found a lot of problems there, but it's a good thing that they were fixed. And now we can run our pilot. NPU-based switches are extremely good, so they can adopt the software in several weeks. So they have good performance. They usually have a lot of TCAM, but the biggest problem with them that they cost like traditional ones. So when comparing NPU-based network to MPLS routers, so you will have some problems with pricing. Another interesting thing, that traditional engineers doesn't like new concepts, even they don't like SDN at all. So when you move from your capital to some far parts of your country, you will understand that the far you get, the more guys like MPLS only. So they don't want to even try to understand that there can be another concept. So the typical questions when we came to the first regions were, guys, why do we need them? We have network, it's running, it's okay, we can ask for additional discount from any of the vendors. Why to do that? And so it took us about, I think, several months to involve them in this process. So we made several presentations for them. We had a lot of talk with them, and then they agreed to help us in that. And the last part is security. So as you have some control plane learning, so most of the packets go to controller, all the MAC addresses are learned through it. So there new security issues arise. So actually we didn't pay a lot of attention to this, a lot, but we paid some of them. So it will be another topic for SDN, I hope. So that's all that I was going to tell. Thanks for your attention, and I'm ready to answer your questions.
So I have a question against the so-called open source controllers like OF, ONOS, and ODL. So why did you pick up OF, OpenFlow?
So at the beginning, so there was no P4 at the time at 2015, sorry. There was no P4 at the time, working P4. So it appeared later, and actually there's no problem to integrate P4 into current controllers, so all the service abstractions and all the interfaces, they're the same. So, and the biggest thing why we don't implement something from open source is support. Who will support this? So for BrainFonet, I know all the guys, I can call any of them if something is not working, and for open source, any other questions?
Yeah, I think we're out of time.
Okay. Okay. So, thank you.